Hey guys, this is the last bit of work for the break I want you guys to check out. This is the one video. It's going to be going through kind of just like a lesson on distance and midpoint formula. These two topics are basically in the coordinate plane, how to find the midpoint of a segment and how to find the length of a specific segment. What we're going to do here is just I'm going to go through how to use those formulas and what they're telling us. This is going to be useful for a few reasons. We're going to be using it throughout the year. These are two like staple formulas, and in addition, it's going to be useful for the angle pairs project. For the angle pairs project, there's a few problems where you need to use the distance and you need to use the midpoint formula. So just want you to be comfortable with the formulas. So here we go. So to start here, this first page just kind of just goes through just to refresh your memory on coordinates. We haven't really done anything in the coordinate plane yet this year, so I just want to make sure everyone's comfortable with basic coordinate plane facts. For the coordinate plane, we have an x and we have a y coordinate. X tells us whether we're going left or right, and y tells us whether we're going up or down. If we have a point 7, -3, if it's positive, it's going to the right 7, and it's a negative, so it's going to go down. If we had -5, 4, we would go left the 5, up the 4. So again, the positive tells you right, negative tells you left. Positive tells you up, negative tells you down for y. And each one of these points, we start from the origin at all times when we're starting to plot the point. So I'm just going to say, let's say these points are, let me say x, and let's say y. So if I'm plotting x, I would go to the right 7. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 3. So this would be my point for x. For y, I'm going to go -5. Okay, sorry about that. And if we're doing -5, 4, we're going to go to the left 5. So 1, 2, 3, 4, 5. And then we're going up 4. And again, each point is only, even though it's two coordinates, only 1 point. So that would be like how those would look. So quickly, again, this is just making sure you're comfortable. It says which point has coordinates 2, 3. So if we start at the origin, right 2, up 3, that's going to be point B. For number 2, it says, what are the coordinates of point G? So for point G, this is where it's located. We're going 1, 2, 3, 4 to the right. So it's going to be 4 positive. So this is out and this is out. And then we're going 3 down. So it's going to be C. When we go down, it's a negative. For the next one, for 3, it says, what's the x coordinate of point F? So for point F, it's 1, 2, 3, 4 to the right. So it's going to be a positive 4. Give the coordinates of each point listed. I'll just put these quickly. If you guys want to, pause the video and try to take a second to list out the points to see if you get them correctly before you unpause it. So for A, it's going to be 2 to the left, so it's -2. And then it's up 1, 2, 3, 4, 5. So it's -2, 5. Okay, so once you do all of that, you end up getting the following for all of the coordinates. Again, just take a minute to pause your video if you have any questions. Ooh. What's a good circle? And if you have any questions, you can just feel free to ask when we come back to class. All right, here we go. So for the next one, it says use the coordinate planes below to answer the following questions. I'm going to zoom out a bit so we can fully see the questions. So for A, it says to list all points in the second quadrant. So in case you don't remember what the quadrants are, let me use a different color here. The quadrants are, we always use Roman numerals for them for some reason. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. It goes counterclockwise against the clock, starting with 1, 2, 3, and 4. So it says to list all points in quadrant 2. So this is quadrant 2 up here, etc. So the issue is, in the quadrant, it's only point V. A lot of people will put Q, they will put T, but those points are actually on an axis. They're not considered to be in the quadrant itself. So the only point in quadrant 2 would be point V. Moving on to the next one here. For this one, it's asking you to plot the points. So again, just some practice with that. It's going to be -6, then up 3. I'll just label them so we know what I'm talking about. That's K. 2 for it, and then -4. So our in. Again, feel free to pause the video and try to plot them yourself, and then check your answers. 0, -3. This is P. 4, 0. So R. S, and lastly 1, 5 for T. Alright, so that's what that should look like when you plot those points. Alright, so we got just a little review in with these different, with the coordinate plane. And now we're going to basically get to the formulas. If you look at number 1 here, it says given the segment AB, let's put a little line up there, given the segment AB with midpoint M, find the values. So this is just making sure that you guys understand what a midpoint is. So at this point, we've been speaking about midpoints since literally the first week together. The midpoint is a point which splits a segment into 2 congruent parts. So immediately upon knowing this is a midpoint, you should have known that these 2 pieces were congruent. Now it tells you that AM is 3x, and it also tells you that AB, so that's the whole thing, is 24. So again, make sure you follow the letters. So, and then you're asked to solve for x. So you can do this 2 ways. You can either say, since this is 3x, this is 3x, and then you can do the equation 3x plus 3x equals 24. Or you can just say, okay, if this is a midpoint, I know that I can just take this 24 and divide it by 2, and therefore both of these are 12. So my other option could be just 3x equals 12. Either way, when I solve the equation, I get 4. And then I would go back and figure out these. Again, I already told you when you divide by 2, they're both going to be 12. All right. So for number 2, this one is kind of thinking along the way of what's going to happen with this theorem before we actually get to telling you the exact theorem. So this is my segment AB. I'm using my tablet today, so it's not as fabulous as me writing on the screen. This is my segment AB, and it actually defines the coordinates of the midpoint. So if you think about what a midpoint is, again, it's in the middle, it splits it into 2 congruent parts. So if you know that, and you're trying to find the midpoint of this, you would basically look for the thing that split it so it was equal on both sides. So you would say, all right, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know that whatever is going to be splitting this in half is going to make it 5 and 5. So I would go for this point right here, because that's the point that's going to make this 5 and that's going to make this 5, because the whole thing is 10. And that's just from counting. So the midpoint would be the point 3, 0. Because that's where it splits it, so it's 5 and 5 on both sides. So with that in mind, let me tell you guys what the formulas are. The 2 formulas, so we've got 2 formulas we're going to be dealing with today. One is distance, one is midpoint. So the distance formula tells you the length of a segment. And the midpoint formula gives you the coordinates of the midpoint of a segment. So when it comes to the midpoint, keep in mind that your final answer is going to be a point. So it's going to be something with an X and something with a Y coordinate. It's a point. So you need to be able to plot it in the coordinate plane. The distance formula is not a point. When you finish with the distance formula, it's just going to be a numerical value telling you the length of a particular segment. So it could be it's 7 units, 3.2 units, whatever it is. But it's going to be a measurement. So this one's going to be, again, a point, corners of a point. This one is going to be the measurement, sorry, a measurement. And how is it telling you the distance? It's because it's telling you, or why is it called the distance, I should say? It's because it's telling you the distance between the two endpoints. All right. So for this, if I get started here, I would start off by just giving you guys a formula. The formula for distance is d equals square root. It's going to be x1 minus x2 squared plus y1 minus y2 squared. Midpoint is going to be, it's capital M, equals x1 plus x2 over 2, comma, y1 plus y2 over 2. So for the midpoint, it's the average of the x's. Remember, averages when you add them up and divide. And it's the average of the y's. And for the distance, it's a little different process. It's a little longer. Distance tend to have some more mistakes because of the negatives and squaring, and that's just an end-all problem for us math teachers with students. And squaring negatives, when you square a negative, it is a positive. So that tends to be an issue with the signs and stuff like that with the squaring. Note that with the distance formula, it's subtraction in the parentheses and it's a plus in the middle. I like to tell students, like, as far as, well, obviously we're in a different format right now where you guys can use your notes and pretty much everything is open notes. But normally if it comes to memorizing it, I try to say the T's in the middle, so the plus sign's in the middle. And then these other two are subtraction. So I'm going to go through and just get the distance and the, apply the distance and the midpoint formula to both of these first two problems. So for number one, this is what you're going to do. You're going to start off, you have 2 points. The first point is going to be your x1, y1. And your second point is going to be your x2, y2. Why? Simply because this one's first and this one's second. And the x and y is obviously because the first point is x, it's alphabetical, and the second point is y. So that's why we're saying x1, y1, x2, y2. So those are the values that we're going to be plugging into our formulas. I'm going to go through and do the midpoint first, just because that one's a little easier, and then I'll go back and do the distance for both. So since I'm doing the midpoint here for number one, again, it's capital M equals, again, I have my plugins over here. So it's going to be x1 plus x2. So x1 is 3 plus x2 is 4 over 2. y1 is 5 plus 2 over 2. Continue with the math here. So 3 plus 4 is 7 over 2. And 5 plus 2 is also 7 over 2. Now, you can technically leave it as a fraction, so that's fine. But because it's a point and we have to plot it, I normally prefer to get a decimal for these just because I know what I'm plotting. But again, you can leave it in fraction form as well. So that is how we get the midpoint. Pretty straightforward. We're going to do the same thing for number 2. So for over here, we again would label the first point x1, y1, and our second point is x2, y2. All right, then we go ahead and start plugging into the formula. Again, the formula here is going to be x1 plus x2, so it's going to be negative 5 plus, put my capital in, negative 9 over 2, comma, and then it's going to be 4 plus negative 7, put it in parentheses if you want, over 2. All right, equals, this is going to be negative 14, let's see, 4, negative 14 over 2. And this is going to be negative 3 over 2. Answer is going to be negative 7, comma, negative 1.5. That's our midpoint. All right. Okay, so the next thing we need to do is the distance formula. So the distance formula is, again, where we tend to have a little bit more mistakes. So key thing is just to be careful, take your time, watch your signs, don't ignore any operations. So if the formula has a minus sign in it, you need to put that minus sign. It's never not put. If it has a plus sign, you need to put that. If it's being squared, you need to put that. If it has parentheses, you need to put that. So follow exactly what the formula has. So let's plug in. I'm going to start with D equals. Again, distance is not going to be a point. It's going to be a unit of measure. It's going to be one number in the end. So for this first one, again, it's going to be x1 minus x2. So in my parentheses, I'm going to have 3 minus 4 squared. Plus is in the middle. And then the other set of parentheses is 5 minus 2 squared. Keep going. I deal with my parentheses now. 3 minus 4 is negative 1 squared. 5 minus 2 is 3 squared. A negative squared is always a positive, never a negative. So this becomes the square root of 1 plus 9. So 3 squared is 9. Then I go ahead and add those up. I end up with the square root of 10. So that is D. Now, a lot of the times we'll tell you you can leave it as a radical. So you could technically leave it as a square root of 10 since it's going to be a decimal. But there are times where you need to go ahead and get the decimal, like especially if you look at the angle pairs project that you're getting. It says to find the perimeter. So you need to figure out the exact side. So in that case, you can't leave it in square root form. So for this one, just so you know what I got, I get 3 point. So I just did the square root of 10 in my calculator. 1,622, etc. Now again, we're only going to round to the nearest tenth. So I just want to review the rounding rules because it just annoys us to the 10th degree when students round wrong. So if we're rounding to the nearest tenth, this is the 10th digit, the first digit after the decimal. And we only look one digit back. So some students will have a problem like 1.449, and then they'll say, oh, this is going to make that, and then this is going to make that. You don't do that. When you're rounding, you only go one place. So even though that 9 is there, that's not what we look at. It's completely irrelevant. You only look at the very next place, and that's less than 4. I'm sorry, it's less than 5. So if it's less than 5, you stay. So my answer would just be 1.4. I don't look at the 9 and make that a 5 and therefore that a 4. Therefore that a 5. Anyway, so now we're just going to round. So this is greater than 5. So if it's 5 or higher, we round up. So the answer for this is going to be the distance or the length of this particular segment is 3.2. And it would be units. All right, for number 2, we're going to do the distance as well. So it's going to be distance equals square root. Again, just fill in the first time. You don't have to show every single step like I did here, but I at least want to see the filled in one, and then you can kind of skip some steps throughout. But for this one, it's going to be negative 5 minus a negative 9 squared plus 4 minus a negative 7. Oh, sorry, this is minus a negative 7. I hope you can see that. It's right on the edge there. So for this, you want to be careful because a lot of students make mistakes with these signs in situations like this. Some students will think, okay, the formula has a negative, so I don't need my negative in the number. Like, they'll just put a minus one time. That is so wrong. If there's a minus in the formula, it has to always be prevalent. So it's going to be negative 5 minus, which is what the equation called for, or the formula called for. Then it's a negative 9. So a double negative, now we have to apply the appropriate rules. Again, this is where sign number error range comes in. A minus is a plus. So this ends up being the square root of 4 squared plus, this is going to be negative 3 squared. So the square root of 4 squared is 16 plus 9 ends up being the square root of 25. The answer is 5. So that is the length from, it doesn't have letters, I thought about to say A to B or something, but it doesn't have any segment. But that would be the length of that segment from one point to the next. All right, so we're going to do like maybe 2 on the next page, and then I think there might be a perimeter one that we'll look at quickly. So for number 1, it says to plot the points and connect KV. So here are points up here for KV. And let's plot them. So we have negative 6, positive 3, and we have 2, negative. Let's connect those. Now, so that's the first thing, A. A is done. It says to calculate the midpoint. So again, our midpoint formula is M equals x1 plus x2 over 2, y1 plus y2 over 2. So let's do that for this one. Again, if you need to label it, x1, y1, x2, y2. That's what I'm going to plug in. So it's going to be M equals, midpoint is going to be negative 6 plus 2 over 2, and 3 plus negative 3 over 2. So this ends up being negative 4 over 2, and this one ends up being 0 over 2. So we end up with negative 2, comma 0. Next thing here, it says to plot the midpoint. So plot the midpoint means we want to put it on the graph. Let me get a different color here. And we're going to plot this on the graph. So this is my midpoint. So it's going to be negative 2, 0. It's right there. Now, keep a few things in mind because this can help you when you're actually solving them. If I got a midpoint over here, I would know I was immediately wrong because the midpoint has to be on the segment. It's no way something's a midpoint and it's not directly on that specific segment. So it can't be up here. It can't be over there. So it has to be dead center, and it's splitting it into 2 equal parts. So that's the stuff you need to remember about a midpoint. So keep that in mind. So when I look at it, it looks like it's right about in the middle. And on top of that, it's on the line. So I'm going to assume that that's the correct midpoint. So what I also want to do, or what I also want to see you do, is to mark these congruent. Oh man, I deleted my line. Hold on a second. Let me change colors back. And the reason I want you to mark it congruent is just again further clarifying that you know what a midpoint is, that it's splitting it into the 2 congruent parts. So that's what I would want to see on the graph. And then for D, it says to calculate the length of KV. So for KV, again, I'm doing distance formula whenever it says length. It's the square root. It's going to be negative 6 minus 2 squared plus 3 minus negative 3 squared. D equals the square root of negative 8 squared plus negative 6 squared. Sorry, that's not negative 6, it's positive 6. 6 squared. And then we go ahead and do that. We end up with the square root of 64 plus 36, which equals the square root of 10, which equals, square root of 100, which is 10. Next problem. Oh, I'm sorry. The next thing says to calculate Km and MV. Km and MV, this is M here. I didn't label it. But that was M, my midpoint. And because these are equal, and I know that this whole thing is 10, I know that both of these are 5. So Km and MV are 5. All right, this will be our last example, guys, number 2. And let me just also just give you guys a concept. So if you're trying to find the perimeter of a triangle, you have 3 different points. You're going to need to do distance formula. This is just in reference to the one that's on the project. If you want to find the perimeter, you need to find the distance of all 3 sides. You're going to have to do distance formula 3 times. You would have to do it for TU. You would have to do it again. Sorry, here. There we go. You would have to do it again for US, and you would have to do it again for TS. So you would have to do distance formula 3 separate times. And then perimeter is when you add them up. So let's say we got 7.1, 3.8, 6.9. The perimeter would therefore be me adding up all of those sides, okay? So that's 10.9, 11.8, 17.8. Would be the perimeter if those were the random made-up values. All right, so let's do this last problem on number 2, and then we will be done, and you guys can have a fabulous week off. Miss Berryless. All right, so it says connect the points again, so let's do that. We have 6 and 4. 6, 4. K and negative 10, 8. All right, so here's my second this time. And I need to find the coordinates of the midpoint. So I'm going to start with my midpoint formula. M equals, again, x1, y1, x2, y2. So it's going to be 6 plus negative 10 over 2, and 4 plus 8 over 2. It's going to be negative 4 over 2, and 12 over 2. It's negative 2, 6. So that's our midpoint. Negative 2, 6. My line's a little off, so let me just go and erase it and make it better. It's probably not like wrong, but as you can tell there, it's not on the line, so I do need to make sure I straighten my line out, because you shouldn't have a midpoint that's not directly on the segment. So let me do it with my, do it with my screen pen here. Oh, it's still a little high, but it's a little better than the first one. There we go. Okay, so there we go. So that is my midpoint, and again, I'm going to label it, and what was it supposed to be labeled? M, I guess. All right, so here's my midpoint M. Excuse me, it says calculate the length of KV. So calculating the length of KV is distance formula. So it's going to be 6 minus a negative 10 squared plus 4 minus 8 squared. So it's going to end up being the square root of. This is a plus 10. So it's going to be 16 squared plus negative 4 squared. 256 plus 16. 272. So the square root of 272 is 16 point. Again, I'm just going to show you what the whole number is, and then we'll see what the rounding is together. 6.49, yada yada. Again, all I need to look at is a 9. This is going to make this go up, so it's 16.5. All right, and then the last one says determine the length of MK and KV without using the distance formula. I already did that earlier. I didn't use it. We know this is a midpoint, so these are equal. So if we just figured out that KV was 16.5, then these two halves, you're just going to divide it by 2. So 8.25. So they're both 8.25. All right, have a great weekend, guys.